Good morning, Pirates. Thank you to those of you who came to the Zoom this morning. It always makes my day better when I see your faces. If you weren't able to come today, hopefully you watched the video on our schedule for the next 2 weeks. We have about 14 days until the exam. I think it's actually exactly 2 weeks from today. And we're going to spend a lot of the remaining time doing mock exams. Please make sure you take a look at the schedule, the free response questions we've done already. Print out before the exams those 2 review sheets that I uploaded. And you also want to take a look at the actual schedule with the video. The other thing I posted today was your homework for today. That's type 7 free response questions. And of course, this packet, I always give it so we can go over what these questions will entail before, you'll start with this tomorrow. Okay, so we break the others into 2 separate categories. Typically, they are implicitly defined functions, and what that means is you'll see a table or a chart or something symbolic that you have to manipulate. And you'll have to be able to use the product rule, the quotient rule, or the chain rule with those types of problems. So sometimes it'll look like h of x equals m of x, I don't know, times n of x. And so you're just going to have to model the chain rule. I'm sorry, model product rule using m and n and then plug it in from the table. Okay, know how to find the second derivative, including substituting in for the first derivative. So if you get this notation and let's say dy dx equals xy, when you derive this to get the second derivative, you got to remember to plug back in dy and dx. You also got to remember to put dy dx whenever you take the derivative of y. Analyze the derivative to determine the relation has horizontal or vertical tangents. This is where we're either we have some sort of rational function, so we're looking for the numerator to equal 0 or the denominator to equal to 0, depending on whether it's horizontal or vertical. Write and work with lines, tangent. I don't know why I didn't just say write and work with tangent lines. This is where you might have to estimate a point close by. You're going to have to write a tangent line. We see that in the one free response question today with an inverse function. And then finding extreme values. So it's going to be necessary for you to understand that extreme values happen at the end points or where the slope equals 0. It could be on a graph or it could be in a table. And then the last kind of problem we typically see is a related rates problem. You need to know how to set up and solve those problems. You don't have to memorize the formulas now because this is an open note test, but I certainly think you should be familiar with most of them. Be familiar with the standard types of related rate situations, so like the ladder falling, the boat problem, something leaking from a cone or a cylinder. And then know how to differentiate with respect to time. That is to find dy dt, even if there's no variable in the given equation. Interpret the answer in the context of the problem. So if the second derivative is decreasing, then that would mean the rate at which something is falling out is slowing down. And then unit analysis. So that's type 7. We did take a look at your homework problems today during the Zoom. As you can see here, this is exactly what I was talking about in the first portion of the type 7 overview. We're looking, here we have a chart, and then here we have a function. And so I asked them this morning, like, what's the first thing you think of when you see this? And Julia absolutely was like, chain rule. That's great, because when you recognize that the derivative is chain rule, maybe later on when you have to derive it, it's chain rule. And so part A, explain why there must be a value for R such that h of R equals -5. CJ loves these. It's IVT. These are his favorite problems now. Part B, explain why there must be a value C such that h prime of C equals -5, and that's going to be MVT. So we see IVT, then MVT. Let W be the function given by W of x equals 1 to G of x f of t dt. Find the value of the derivative at 3. This is a fundamental theorem of calculus. You have to remember here that when we derive both sides, one second, we derive both sides of this, what we're doing is essentially getting rid of the integral symbol. But you have to take G of x and plug it in for t. So we've got f of g of x. Now typically if it's a number or it's an x function, we multiply it by the derivative. But since this is all symbolic, it's going to be times g prime of x. Right? And so now it's just, as you all like to quote Mr. Palmer, a simple plug and chug problem. And part D is going to ask for the inverse derivative because you're going to need the tangent line at the inverse. They give you that x equals 2, so you go to the chart and you find out where g of x equals 2, which would be right here, which would make that the point. And then this, look up the inverse derivative rule when you're going through that one. Okay, and then the second problem I gave you, scroll down, keep going. And see here you can see, and again, if we recognize right away chain rule, product rule, we're in good shape for that problem. Okay, and then the last one, I gave you a piecewise function. It wants to know if it's continuous at x equals 3. Remember, to be continuous, the left has to equal the right, has to equal the point. So you got to plug in the 3 to see if the left equals the right first, the limit. If it doesn't, then it's not continuous. If it does, then plug in, figure out which one is f of 3, which would be this function here. If they're equal, it equals a point, then it's continuous. Average value, well, average value is not tested. It's a small part of finding this integral. So I would like you to at least integrate this thing. You're going to need to integrate this by separating the interval from 0 to 5, right? From 0 to 3, and then from 3 to 5. And then the final part says, suppose the function g is defined by g of x equals this new piecewise function where k and m are constants and g is differentiable. This is a huge hint right here. If it's differentiable, we know two things. We know that k root x plus 1 equals mx plus 2 at x equals 3. And we also know that g prime of x from the left equals g prime of x from the right, at x equals 3. And so what you'll create is you'll do these two portions separately. You'll get two equations, and then you'll solve it by systems. All right, so tomorrow we'll talk about these in the Zoom, and then I'll assign some more focus topic 7, and we'll go from there. Have a great day.